Take a moment. Look up at the night sky. Really look. It seems peaceful, serene, almost untouched, a canvas of tranquility. But beneath that calm, a new kind of race is quietly underway, accelerating every day. A race, one that could redefine power, reshape economies, and determine wealth distribution for centuries to come. This isn't about national glory or planting flags on distant worlds. It's a cosmic gold rush, a grand competition unlike any other in human history. It's a scramble for the almost unimaginable riches hidden within asteroids, those floating islands of resources, moons, the silent sentinels of our solar system, and even the surfaces of distant planets. The stakes are almost too high to comprehend, nothing less than the future trajectory of our civilization, the very shape of things to come. This contest is not being fought in screaming headlines or breaking news alerts, but in the hushed tones of secret government files and the strategic discussions of corporate boardrooms. The horizon of opportunity has dramatically expanded beyond the confines of Earth, and the new pioneers are not just astronauts but also visionary astrophysicists, brilliant engineers pushing the boundaries of what's possible, and audacious billionaires willing to bet their fortunes on the future of space. They are all meticulously plotting their claims on untouched worlds, staking their futures on the cosmos. Satellites and deep space probes are no longer just scientific instruments. They are the new prospectors, diligently scanning distant asteroids and celestial bodies, searching for the most lucrative targets, the mother lodes of the solar system. While we go about our daily lives largely unaware, a completely new map of the solar system is quietly being drawn, redefined by potential and profit. A map not of continents and oceans, but one of platinum, vast reserves of water ice, the lifeblood of future space settlements, and strategically important rare Earth elements, essential for our advanced technologies. Imagine a future where materials currently considered rare and precious become commonplace, readily available, and where sprawling space habitats are constructed from resources mined directly from the lunar surface or captured asteroids. This bold vision is what truly drives the new space race, fueling the ambitions of those who dare to dream big. It's a race towards abundance, unprecedented technological leaps, and ultimately, humanity's permanent expansion and establishment amongst the stars. But this incredible promise comes hand in hand with significant peril and unforeseen challenges. The competition is already incredibly fierce. The rules of engagement are largely unwritten and untested, and the engineering and logistical challenges are, quite frankly, immense, requiring solutions we haven't even conceived of yet. Nevertheless, the cosmic gold rush has undeniably begun. The starting gun has been fired, and its ultimate outcome will irrevocably shape our destiny, determining the kind of civilization we become. The apparent silence of space is deceptive. It hides a growing storm of activity, a flurry of innovation and ambition. The ultimate finish line? A future so advanced, so interconnected, that we can barely even begin to imagine its possibilities. The key players in this grand endeavor, visionary leaders, powerful nations with their own strategic agendas, and massive corporations with the resources to turn dreams into reality. All of them are relentlessly racing for the stars, each with their own unique motivations and goals. And the ultimate prize? Nothing less than the keys to unlocking the next great era of human civilization, a future amongst the stars. What are these celestial treasures that drift silently in the vast expanse? What secrets do they hold, and what potential do they offer to those who dare to reach for them? They're the fundamental building blocks of our world, the very elements that form our landscapes, our cities, and everything we hold dear. And perhaps even more significantly, they represent the cornerstone of our future among the stars, a future where humanity extends its reach beyond Earth. Asteroids aren't just inert rocks floating aimlessly in space. They're treasure troves, often packed with valuable metals like platinum, a highly sought-after resource. Palladium, another rare and precious metal with a wide range of industrial applications, and iridium, a metal so rare and valuable that it's used in everything from electronics to medicine. These materials are absolutely crucial for the advancement of technology and the continued growth of industry here on Earth and beyond. Incredibly, a single small asteroid, seemingly insignificant in the grand scheme of the cosmos, could potentially hold more precious metal than all of Earth's mines combined, representing an almost unfathomable concentration of wealth. But perhaps the most valuable resource of all, the one that could truly unlock the potential of space exploration, might be water. often found frozen in the perpetually shadowed craters of the moon, or securely locked within the icy composition of distant asteroids. Water, of course, sustains life as we know it, provides breathable oxygen for astronauts venturing into the void, and, when split into its constituent elements of hydrogen and oxygen, becomes a powerful and efficient rocket fuel. Access to readily available water in space effectively means the creation of cosmic gas stations, strategically positioned throughout the solar system. This in turn enables ambitious missions deeper and deeper into the solar system, pushing the boundaries of human exploration. Furthermore, the moon's regolith, the layer of loose dust and rock covering its surface, holds significant quantities of helium-3, a highly sought-after isotope with the potential to fuel clean and virtually limitless fusion energy here on Earth. And let's not forget the more common yet equally vital resources like iron, nickel, and cobalt, which are also found in abundance throughout the solar system. These materials are absolutely perfect for constructing tools, habitats, and other essential infrastructure directly in space, reducing our reliance on resources from Earth. The exploitation of these extraterrestrial resources could potentially solve Earth's growing shortages, and in the process, launch a multi-trillion-dollar space economy, transforming our civilization in profound ways. The nations and corporations that are first to successfully mine and utilize the resources of space won't just accumulate immense wealth, they'll effectively control the critical supply lines that will fuel humanity's inevitable leap into the cosmos, shaping the future of our species. That's precisely why this race to unlock the resources of space is so incredibly urgent, and why the stakes are so extraordinarily sky-high. The competitors? Old rivals and bold newcomers. The US, through NASA and private partners, is racing to the moon, not just for science but to secure resources. China's lunar missions are systematic prospecting campaigns aiming for dominance in space. Smaller nations like Luxembourg are attracting startups with legal frameworks for space mining. Japan, India, and Russia are all making their moves, each with unique strengths. But private companies, SpaceX, Blue Origin, and startups like Asteroid, are the wild cards, driving innovation and lowering costs. These corporate pioneers are agile, profit-driven, and determined to master space resources. The arena is crowded, and the race is accelerating. How do you mine a speeding asteroid? The plans are as bold as the goal. First, prospecting fleets of small satellites scan thousands of asteroids, analyzing their composition from afar. When a target is found, robotic probes land, drill, and confirm what's inside. For small asteroids, the bag-and-grab method captures the rock and moves it to a safe orbit for processing. Larger asteroids require on-site mining. Robotic rigs anchor, excavate, and extract resources. Techniques like thermal ablation and optical mining use sunlight or lasers to release valuable materials. Space-based refineries turn raw materials into fuel or building blocks for space infrastructure. High-value metals could be sent back to Earth in return capsules. The logistics are staggering, but the economic incentive is driving rapid innovation. Science fiction is becoming reality, one mission at a time. The path to space mining is fraught with challenges, a cosmic gauntlet thrown down before those who dare to reach for the stars. It's not just about the technological hurdles, it's about navigating a landscape of risk unlike anything we've encountered before. Autonomous robots must operate millions of kilometers away, venturing into the inky blackness where communication delays can stretch into agonizing minutes. These aren't your factory floor automatons, they're pioneers on the edge of known space, solving problems without human help. Imagine a critical system failure light years from Earth with no engineer to troubleshoot. The robots must be self-reliant, capable of diagnosing and repairing themselves in the face of the unexpected. The cost, billions per mission, a staggering investment that dwarfs even the most ambitious terrestrial mining operations, with no guarantee of success. Every launch is a gamble, every mission a roll of the dice against the unforgiving laws of physics and the unpredictable nature of space. A single failure, hardware malfunction, launch anomaly, or a barren asteroid, could mean financial disaster. The stakes are astronomically high and the margin for error is vanishingly small. Only the wealthiest nations and corporations can play this high-stakes game. It's a playground for titans where fortunes are won and lost on the turn of a thruster. Legally, it's a gray area. The Outer Space Treaty forbids national claims but is silent on private resource rights. This legal vacuum creates both opportunity and peril, a Wild West scenario playing out among the stars. Some countries allow their companies to mine, but there's no global agreement, setting the stage for conflict. The potential for disputes over resources and territory looms large, threatening to turn the promise of space exploration into a battleground. Space itself is dangerous. Radiation, micrometeoroids, and unpredictable asteroids threaten every mission. These are not abstract risks, they are constant, tangible threats that demand respect and meticulous planning. Many asteroids are loose rubble, spinning unpredictably, making landing and anchoring perilous. It's like trying to build a skyscraper on a rotating pile of sand. The risks are immense, and the rules are unclear. Every step is a leap into the unknown. The frontier is open, but it's anything but safe. Space mining makes Earth's Wild West look tame. It's a new era of exploration, fraught with peril and uncertainty, but also brimming with the potential to reshape our future. Beneath the surface, a secretive race is unfolding. Intelligence agencies monitor rivals' launches, decode spacecraft missions, and analyze data for hidden agendas. Dual-use technologies blur the line between science and strategy. Companies hoard astronomical data, training AI to spot the richest asteroids before anyone else. The best algorithms become secret maps to cosmic treasure. With no clear laws, claim jumping and secrecy are rampant. The real race isn't just about getting there first, it's about keeping your target hidden until it's too late. In space, information is the ultimate weapon. We stand at the threshold of a new era. Space resources could end Earth's resource wars, fuel green revolutions, and launch us to other worlds. But if unchecked, this race could export our worst habits, inequality, conflict, and exploitation, into the cosmos. The choices we make now will shape the future among the stars. We need a new global framework for peaceful, sustainable space development. The race is on, and the outcome is unwritten. Will we use the wealth of space to elevate all humanity or repeat old mistakes on a cosmic scale? The next chapter of our story will be written not by the stars, but by us.